Hey, this is Mr. Coker with my second video for my geometry class of about proportions and similarity, or similarity and proportions, however you want to think of it. So, the last video I made had to do with finding scale factors. This one has to do with finding a missing side. We're going to assume that these two polygons, these rectangles, are similar. So if they are similar, what that means is that they have the same shape but different sizes. I said that in the last video, but if you need to hear it again, or if you just didn't watch the last video, there you go. Anyway, similar objects have the same shape but different sizes. I said it again because it's very important. Now, how are we going to find a missing side? This right here gives us more than enough information. In the last video, I mentioned about finding scale factors, where we would find two similar sides or two corresponding sides and divide them and reduce a fraction, and that will tell us the scale factor. Now, on this one, we know the bottom is 4 and 12. Okay, we know that the bottom of each rectangle, one is a measurement of 4, one has a measurement of 12. We also know that one side has a measurement of 21 and one side is x. The 12 up here we can essentially ignore. That's unneeded information. We only need two sides from each figure. We're good. What I'm going to do is I'm going to write this as I'm going to write it as two fractions. I'm going to put x over 4. Okay, the order doesn't matter, but I'm doing x over 4. How you do it doesn't matter as long as you're consistent during the problem. If I put the side value, the side measurement on top on my first fraction, I better do the same in my second fraction. So now I have, on the second fraction, I'm going to put the side measurement of 21 over 12 and make them equal to each other. Okay. Now, this is an equation that can be solved. Does it look like an equation that can be solved? Yes? You're saying, I'm sure everyone watching is like, yes, this is an equation that I can't wait to solve. Right? Well, hopefully. Probably not. Anyway, here's what we do. We cross multiply. Here's why we cross multiply. I've got to get x by itself. X is being divided by 4. Right? Let's get rid of the 4. I'm multiplying. Now, I could do this in two different ways. I can just multiply each side by 4. I could also cross multiply. Here's why I won't do cross multiply. It's because it'll make it easier for the future. That's why. Because in the future, there will be, the next video I'll make is going to be talking about solving for x, like when we have an expression instead of x. So it's going to be, it's going ahead and getting used to cross multiplying is probably the best thing you can do. Anyway, here we go. I'm going to do x times 12 equals 4 times 21. X times 12 equals 4 times 21. Cross multiplying. 12 times x times 12 is 12x. 4 times 21 is 84. Okay? Now, divide. We have 12 times x. We do the opposite operation, which is to divide. And we get x equals 7. 84 divided by 12 is 7, not 12. I was adding the previous 12 instead of 7. Anyway, the answer is x equals 7. So, one more time, I set up my fractions. X over 4, 21 over 12. Okay? Secondly, I cross multiply. 12 times x is 12x. 4 times 21 is 84. Okay? And then it's a one-step equation. Divide each side by 12, we get x equals 7. We're dividing by 12 because 12 times x is multiplication. We want to do the inverse operation, which is divide. Again, you could also multiply each side by 4 and get 21 times 4, which is 84, and then divide it by 12 and you get 7. You're doing the same thing either way. I just want to point out, I think it's better to do it this way. So, what you want to do, set up the fractions consistently. You could put 12 over, you could have put 4 over x and 12 over 21. Does not matter what order you do it as long as you are consistent. Secondly, once they're set up, you cross multiply. Thirdly, it's a one-step equation now and you divide and you get x equals 7. That's it. Shouldn't be too difficult. At least with practice it will not be. So, this video is already over 8 minutes and I've done one problem. Should I do like more? No, I won't, don't worry. I'll do more in class though, so make sure you're in class. You all have a great rest of your day, and thanks for watching.